Alright folks, today we're working on 8.3, which is the rational root theorem, which allows us to do some interesting things kind of really quickly. So given the polynomial, p of x equals a x to the n plus b x to the next number down, so if this was 4, this would be 3, plus 2, and then so on and so forth, all the way down until you get to a constant c, which is just really the last set of, it's the last term, and really it needs to be a number. Be a number and not like a thing with an x in it. Then we can say that x equals p over q contains a set of possible solutions of the polynomial where p is the factors of that last term, so the factors of the last term, and it's just a list, and q is the factors of a, which is the coefficient of our first term. And this isn't going to make a whole lot of sense right now, but we're going to go through it. Just copy this down anyways. So then, if p, so we put this in our polynomial, if we put this ratio, if we do this with long division and we get a remainder of 0, then x is a solution or a 0. So this says that we get a remainder of 0 using either long division or synthetic division, but I like to use synthetic division since it's much faster. So, example 1. Use the rational root theorem to find the roots of x squared plus 9x plus 14. This is going to require a bunch of paper. So if you don't have a bunch of paper, pause this video right now, go get a bunch. Okay, so we need to find the factors of this last term, this p, find the factors of the coefficient of the first term, this q, and now we can divide these so that we can plug them in and test. So our last term, our c, is 14. Our first term is 1, of course. So p, we're looking for all the numbers that divide into 14. So 1 and 2 and 7 and 14, and that's all of them. Q is really easy this time. Q, we've got a number in the front, is just 1. So what we have to do is divide these. So we'll take 1 divided by 1, 2 divided by 1, 7 divided by 1, and 14 divided by 1. And then we just simplify them. So we get 1, 2, 7, and 14. And yes, this is kind of straightforward. Like, why didn't I just write those down? It's going to make a lot more sense the next time. So we have a list of 8 numbers to possibly check. We could have positive and negative 1, positive and negative 1, so we have to have 2 answers here, 2 answers here, 2 answers here, and 2 answers here. Because a positive divided by a positive is 1. A negative divided by a negative is still 1. So we can have both of these. So our next step is to write this in synthetic division form. So our coefficient of the first one, coefficient of the second one, coefficient of the last one, and we're all trying it with, I just try 1 first, positive 1, because you know, it's fun to do. So 1 times 1 is 1, 9 plus 1 is 10, 10 times 1 is 10, 24. Our remainder here is not equal to 0. Therefore, 1 is not a solution. So we say, no, it doesn't work. Let's try negative 1. So we do this again. 1, 9, 14. 1 carries down. 1 times negative 1 is negative 1. 9 minus 1 is 8. 8 times negative 1 is negative 8, which gives us 6, which is not 0. Therefore, no. Therefore is what this 3 symbol means. Not a solution. Okay, we tried both of those. Let's try positive 2. 1, 9, 14. 1 times 2 is 2. 9 plus 2 is 11. 11 times 2 is 22, which gives us 36, which is not 0, therefore not a solution. Okay, let's try negative 2. 1, 9, 14. 1 times 1 plus 1, or 1 plus 0 is 1. 1 times negative 2 is negative 2. 9 minus 2 is 7. 7 times negative 2 is negative 14, and we get 0. Congratulations. Therefore, 0 is a solution. Or negative 2, I'm sorry. Negative 2 is a solution. Okay, so we tried those two. Remembering that the fundamental theorem of algebra says that the degree of the highest exponent, so the degree of the exponent, which is the highest exponent, is going to tell us the number of solutions. Equals the number of solutions. So in this case, we have an exponent of 2. Therefore, we have 2 solutions. So we found 1. We need to keep going until we find the second. So let's try 7. So 7 is 1, 9, and 14. Same as exact 1. 1 plus 0 is 1. 1 times 7 is 7. We get 16. 16 times 7. Oh gosh, need a calculator. Okay, so 16 times 7 is 112. There is no way in heck that 126 equals 0. So therefore, not a solution. Let's try negative 7. 1, 9, 14, 1. Negative 7 is negative 7. 9 minus 7 is 2. 2 times negative 7 is negative 14. 14 minus 14 is 0. Therefore, because our remainder equals 0, therefore it is a solution. When wonderful. So no on this one, yes on this one. So our two solutions are equal to negative 2 and negative 7. And that's how it goes. So what we can say, oh, I forgot to move this down. I'm sorry, guys. What we can say is after we keep testing this over and over, and if you need to pause this and go back until you get the solutions, that's fine. After we keep testing this, when we have found our total number of solutions given by our highest exponent, we're done. We don't need to keep testing those. So we don't need to test 14 at all, because when we tested positive and negative 1, positive and negative 2, and positive and negative 7, we found our two solutions for this equation. So we know that we could plug in these two numbers into these x's, and this would equal 0. Okay, so this is kind of a basic one. This is a quadratic. This is not so important that we need to do this, because other ways of doing this include we could factor this. We could plug this in the quadratic formula. We have other methods in order to try. However, when you get to something that kind of looks like this, so find the roots of g of x equals 2x to the 4th plus x to the 3rd minus 19x squared minus 9x plus 9, there is a little bit more to this. So just like we did in the last problem, we'll say p is equal to the factors of the last term. What divides evenly into 9? 1, 3, and 9. Okay? We look at q, which is the factors of the first coefficient. What divides evenly into 2 is 1 and 2. So our x values we want to test is going to be 1 over 1, 3 over 1, 9 over 1, and also we have 2 of them. So that's the difference between the last one and this one. On example 1, we only had 1 q. We only had to test it once. The second one, though, we have 2 q's. So each of our p's over this q, each of our p's over the second q. And if there's a third q, each of our p's over the third q. So we have 1 over 2, 3 over 2, and 9 over 2. And sometimes, like if we had a nice even number here divided by 2, we might get one of the other values, and that's okay. So the numbers to test: positive negative 1, positive negative 3, positive and negative 9, positive and negative, can't simplify this, 1/2, positive and negative 3/2, and positive and negative 9/2. And I hope to goodness I don't have to worry about that, but I can always make it a fraction if I need to. Okay, don't forget our fundamental theorem of algebra. It says that we have 4 total solutions to this equation. There are 4, the highest exponent is 4, therefore we're looking for 4 roots, 4 zeros, 4 solutions. Okay, so our coefficients, 2, 1, negative 19, negative 9, and positive 9. So when we get a polynomial like this is where where doing all of these is really going to help us. So let's start with positive 1, because I always like to start there. 2 is 2, is 3, is 3, is negative 16, is negative 16, is negative 25, is negative 25, is negative 16, which is not equal to 0, therefore not a solution. Okay, let's try negative 1. So that took care of that one. Being organized is really going to help you out a lot. So make sure that you make yourself a list of these so that you can keep track of what you've already tried and what you haven't. Okay, 2, 1, negative 19, negative 9, and positive 9. 2 times negative 1 is negative 2, negative 1, positive 1, negative 19 plus 1 is negative 18, times negative 1 is positive 18, 9 minus, or negative 9 plus 18 is positive 9, 9 times negative 1 is negative 9, negative 9 plus 9 is 0. Woohoo! It equals 0, so therefore it's a solution. Oh, not solution. There we go. So that one works. So there's one of our 4 possible solutions. Okay, we've tried all of these. Let's go on to 3. So 3 is going to give us 3 Copy our coefficients. 2, 1, negative 19, negative 9, and positive 9. And this should be exactly the same as you did in synthetic division for 8.2. Okay, so 2 gives us 2, times 3 is 3, plus 1 is 4, times 3 is 12, minus 19 is negative 7, times positive 3 is negative 21. Let's make sure I did something not silly. 2 times 3 is not 3. 2 times 3 is 6. Mr. Seaman. 1 plus 6 is 7. 7 times 3 is 21. Minus 19 is 2. There we go. This is feeling a lot better. 2 times 3 is 6. Negative 9 plus 6 is 3. 3 times 3. No, it's negative 3. Negative 6, negative 9 plus 6 is negative 3. Negative 3 times positive 3 is negative 9, which gives us 0, which I knew it because I worked this problem out and it wasn't working, but it is a solution. Okay, so that says 3 is the solution. So that says we tried positive 3. I guess we'll try negative 3 next. 2, 1, negative 19, negative 9, 9. 2 times negative 3 is negative 6, plus 1, negative 5, times negative 3 is positive 3, is positive
12. Negative 9 plus 12 is 3. 3 times negative 3 is negative 9. Negative 9 plus 9 is 0, which means it is a solution. Woohoo! There's 3 out of the 4, and all we've done is 4 of them, so we just worked in order, which is really fancy and nice. That's awesome. Okay, looks like we've got all the 3's. Let's go on to the 9. So 9, 2, 1, negative 19, negative 9, and positive 9. Carry the 2 down. 2 times 9 is 18. I have a feeling like this one is not going to work, but we're just going to play it through just to see what happens. 1 plus 9, 18 is 19. 9 times 19 is 171. Minus 19 is 152. Times 9 is 1,368. Minus 9 is 1,359. Times 9 is 12,231. Plus 9 is, no, that's not going to work. We're just going to say no. No. We're going to get 12,240, and that's definitely not equal to 0, so not a solution. Okay, that one's not going to work, so we tried positive 9, that didn't work. Let's try negative 9 next. And if you want to skip around, that's fine. I just like to work in order. Plus, doing the same thing over and over to me is kind of soothing, as long as I don't make mistakes like I did on negative 3 up there. That was embarrassing. Negative 9, positive 9, 2. Okay, so 2 times negative 9 is negative 18. 1 minus 18 is negative 17. Times negative 9 is 153. Minus 19 is 134. Times negative 9 is negative 1,206. Minus 9 is negative 1,215. Times negative 9 is positive 10,935, which is again 10,944, which is not equal to 0, therefore not a solution. So no on that one, no on that one. The 9s didn't work out. Okay, so that's all of our whole numbers. Let's try positive 1/2 first. Maybe we'll get lucky. So positive 1/2, 2, 1, negative 19, negative 9, and positive 9. Okay, so 2 times plus 0 is 2. 2 times 1/2 is 1. 1 plus 1 is 2. 2 times 1/2 is 1. Negative 19 plus 1 is negative 18. Times 1/2 is negative 9. Negative 9 plus negative 9 is negative 18. Times 1/2 is negative 9. 9 minus 9 is 0. Oh my goodness, it worked out. Woohoo! Okay, so therefore, it is a solution. So it looks like we have 1, 2, 3, and 4 total solutions, which is how many we should have. And we're looking at none of them became complex, so that's good. Okay, so x equals smallest to largest. Here are the zeros.
Okay.
I'm moving this down slowly just in case you need to pause it. But this is definitely one of those where you're going to need lots of paper, and you're going to need plenty of time. So if on the quiz or the test, if you need more time for 8.3, just let me know. I will make sure you get plenty of it. I realize these take a while. That's fine with me. We're still going to try 10 problems on our quiz and 8 problems on our test. In the meantime, make sure that you've copied everything down that you need. And really watch out for the small mistakes here. If I had gone through with the original version of this, I would have gotten not a solution, and really 3 is my solution. So there's lots of places to make mistakes. Get a friend to help you out with this. Double check with a buddy, and then let's move on down the highway.